Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about rearrangement reaction. What type of the rearrangement reaction, about the introduction as well as how many key rearrangement reactions are present over there, and how that rearrangement reaction are what are their industrial application in plastics, polymers, pharma, dyes, paint. All these discussion we have discussed in our previous lectures. So today what we are going to talk about, that is a type number, because we know that there are the three key rearrangement reaction. Out of that, one we are going to discuss over here. First one is a 1,2 rearrangement reaction. A type is a 1,2 rearrangement reaction that we are going to discuss today. 1,2 rearrangement reaction means what type of the reaction, what are what we can call it as a named reaction involved in such a kind of the rearrangement reaction. And one most important reaction which is known as Wagner-Mervin rearrangement reaction. Wagner-Mervin rearrangement reaction, that is via non-classical carbocation. What does it mean? Non-classical carbocation means what is that thing, and what type of the compound undergoes that type shows a Wagner-Mervin rearrangement reaction. So let us see the one of the example here. General example we are talking about over here, which is this one. Here we are putting OH group, and here is a tertiary group we are putting at that position. When this is the substrate, this is the starting compound, and which is one of the best example of what we can call it as and when it is treated with the H plus, right? And then when H plus is treated in an acidic medium, and there is elimination, dehydration reaction takes place, and when these get protonated, then form as a cation over there, and you are going to get this type of the intermediate over here. And that intermediate, let me show here, this bond is going to break, and this is a bond over here, and here I am showing this bond, and here is a positive charge, and that type of the intermediate, this I am showing as an intermediate, and this is called as a non-classical carbocation. So this is, and after that breaking, so you are going to get the product. The product will be like this. So this type of the product you are going to get over here. So how we are getting this product? Via this is a intermediate, or what we can call it as a non-classical. This type of the thing is called as a non-classical carbocation. This is a non-classical carbocation. How we are getting as this product? Look at olefin we are getting, and look at this tertiary bond we are getting adjacent to that. How this happen while studying as the details of that Wagner-Mervin. Here generally we are talking what type of the reactions are known as Wagner-Mervin rearrangement reaction via non-classical carbocation. So this is one of the best example of this compound, of this reaction, 1,2 type of the reaction. Let me show you, let me give you one more example over there. So that is about the how the reactions are taking place over here. Let us see another example here which is belonging to as a 1,2 rearrangement reaction. Let us see CH3, then here CH3, CH3, then CH2OH, that is called as a neopentyl alcohol, that is a isobutyl alcohol, not here, make the correction over the starting compound is this one, that is a isobutyl alcohol. This one is a isobutyl alcohol, 1 2 3 4 isobutyl alcohol. This is a alcohol when it is treated with the acidic medium, just we are showing as a H plus. Do you know that H plus means what? This H plus is nothing but it is coming from the acid, maybe from inorganic acid or the organic acid. Inorganic acid like as a sulfuric acid, hydrochloric acid, or nitric acid, and the organic acid like as a benzoic acid, acetic acid. This the meaning of that in acidic medium. What that acidic medium happen, that OH get protonated, because OH is a very bad leaving group, as we know that when it get protonated that becomes as a good leaving group, and so it departs. So after departing that, what you are going to get? You are going to get here CH3, then methyl group here, one hydrogen atom, and here CH2 positive charge present on this. If you observe this carbocation carefully, tell me what is the nature of this carbocation. The nature of this carbocation is a primary carbocation. This one, primary carbocation, right? So mechanism I will show you later on, but here just remember the OH pick up that proton, that becomes as OH2, and then that becomes as a good leaving group, it depart. After that there is a formation of the carbocation, and now there is a hydride now this proton is shifted from here to here. So what do you get here? CH3, then look at CH3, here also as a CH3, and what type of the charge is present over there? Because there is a hydride transfer, that when that hydrogen goes with the heat taking its bonding pair, and that's why we are getting as a positive charge over there. And now if you look at this one, the nature of that carbocation is a tertiary carbocation, as we know that the stability of that carbocation, which carbocation is more stable? Generally tertiary carbocation is more stable than secondary than the primary carbocation. This is the general trend of the stability of the carbocation. Tertiary carbocation is more stable than secondary than primary, and that's why this carbocation is more stable than this one. If this carbocation further treated with the solvent, resulting compound formed will be this CH3 and OH. So we will get as a tertiary alcohol. So these, now look at here, OH is at this position. It is after rearranging within the molecule. This is intermolecular rearrangement reaction takes place, and we got this is a primary alcohol. If you look at this one, this will be the tertiary alcohol. How the molecule how the atom automatically get rearranged within the molecule, and such type of the reaction is known as here the shifting of that hydride 1 to H means hydride shift, H minus shift over there, and they producing the most stable carbocation, which is a tertiary carbocation. And as we know that this is a general trend of stability order of that carbocation, and the above reaction generally goes through primary carbocation, less stable, which convert into stable tertiary carbocation to product by hydride shift, as I already told you that. And then third reaction, this is a second reaction we have seen. Now let us move on to third reaction, which is belonging to again as a 1,2 rearrangement reaction. Let's see third one, famous reaction. Third reaction will be this one, which is called as a Beckmann rearrangement reaction, right? This is known as a Beckmann rearrangement reaction. Rearrangement reaction. Beckmann rearrangement reaction, and this is one of the famous rearrangement reaction, and it is known for the conversion of cyclohexanone oxime to caprolactam occurs via nitroleum ion, and detailed study of that we will see later on. But generally this is the compound which is known as NOH. This is called as the oxime derivative, right? And this oxime derivative generally obtained from, this is cyclohexanone oxime derivative, cyclohexanone oxime derivative, you can call it as a generally oxime derivative, and this derivative generally obtained by the ammonia derivative when cyclohexanone treated with hydroxylamine. These reactions are highly pH sensitive. They proceed at their optimum pH. Optimum pH, what do you mean by that optimum? In industrial chemistry, you might have heard these words: optimum temperature, optimum pressure, optimum pH. Optimum pH means what? The reaction proceed in a economically best way. There is a pH is optimum. If you increase the pH, the yield goes on decrease. If you decrease the pH, yield goes on again as a decrease. Means at a optimum pH where you can get the product of that compound is a maximum as well as economically profitable. That word in industrial chemistry you might have heard this one. So this is called as a this reaction is generally proceed at optimum pH. They are pH sensitive reactions, and this generally when it is treated with the acidic medium reaction, this is taking place generally. Acidic medium sometimes referred as a H2SO4. This is a reaction, and this reaction generally as a Beckmann rearrangement. Beckmann rearrangement reaction. Beckmann rearrangement, the speciality of Beckmann rearrangement, let me tell you, there is a migratory aptitude, means 1 to what type of there are two possibilities. If you see this OH, there are this side, this cis to OH, and this side is a trans to OH. When the migration, there are the this type of the compound you may get over here, that is a caprolactam here, this, and this is a 6-member ring, whereas you will get the 7-member ring over here, this C double bond O and H. This is the compound which we got, that is called as a caprolactam. Caprolactam, which is industrial raw material. From that we can prepare the polymer over there, caprolactam, which is used for the synthesis of that, or maybe as a, I think, nylon. This is one of the starting material or the raw material used for the synthesis of that nylon. You might be knowing that one. But Beckmann rearrangement reaction, let me tell you how it is formed over here. After the in a later part we will discuss the detail of that Beckmann reaction. Here we are generally talking about what type of the reaction that the 1,2 rearrangement, those reaction we are discussing over here only. And here for your information I am telling over there which group is migrating. Look at this is the group which is migrating. Why it is migrating? Always remember, in a Beckmann rearrangement reaction, the group which is migrating anti to that OH or opposite to that OH. Look at, this is anti to OH, and therefore it is going to rearrange. While studying that detailed study of that Beckmann rearrangement reaction, that time we will see the detailed mechanism. So this is enough only information I have given over here. That's more than enough. Now let us look at as a next reaction. Which reaction we are talking about? Rearrangement reaction is a second type, is a B, is a pericyclic reaction. So 1,2 rearrangement reaction, we have seen some of the few example how the 1,2 relative R substituent is changing, that we have seen. Second one is a pericyclic reaction. Pericyclic reaction, that we are going to discuss over here. And what do you mean by the pericyclic reaction? As I already told you that a pericyclic reaction is a type of reaction with multiple carbon-carbon bond making and bond breaking, wherein the transition state of the molecule has a cyclic geometry and the reaction progress in a concerted manner, in a concerted fashion. And as I already told you that concerted means what? The bond making and bond breaking taking place simultaneously. That type of the process, we know that they are the concerted. If you remember the third semesters, that is a nucleophilic substitution reaction at aliphatic carbon, there we have learned SN1 and the SN2 reaction. If you remember, can you recall, do you know SN2 reaction is a concerted reaction? Concerted reaction means where the bond formation and bond breaking takes place simultaneously. So this is one of the good example of concerted. So similarly, this pericyclic reaction also has a cyclic geometry over there. The mechanism that I think in a MSc level we are going to see, but here just for introductory part, you remember what do you mean by the pericyclic reaction and what type of the molecule undergoes as a this one. Let us see first one, that is, suppose we have a substrate like this, then double bond, here is a R, then on the arrow there is a 1,3 shift. 1,3 shift, they are the reversible reaction. All pericyclic reactions are reversible reaction, means product can be converted into as a reactant or reactant can be converted as a product, means they are forward reaction and backward reactions are possible, and so that kind of the reaction are called as a reversible reaction, and they are highly specific one. And here you are going to such type of this R, look at here, R is joined to as a sp2. If you look at here sp2 hybridization, that R over here in the product, this will be attached to as a sp3 carbon atom. So that type of the shifting is known as a 1,3 shift, and the product is formed. And this is one of the example of Claisen rearrangement reaction. This one is a Claisen rearrangement reaction. Claisen, we have heard 1,3 shift is generally occur over there, and this type of the reaction is called as a Claisen rearrangement reaction. And second, one more example I am going to give over here. So this type of the compound, they can also shows the here is R, here you can write as a R dash over here, and this is also as a cyclic geometry over, and thermally it is occurring, that is cyclic geometry. In this case, what is going to happen? The numbers are give here 1, 2, 3, as well as on this side 1, 2 and 3. There is, or it is also known as a 3-3 sigma tropic rearrangement. Sigma tropic rearrangement reaction. So what is happening here? This double bond is attacking on that carbon atom. This double bond shifted from here to here, and this is shifted from here to here. And what do you get over here? C double bond O. Then these R remains as it is. Then we can show there is a single bond. This new bond is formed over there, and then we can write here, and this there will be a double bond. So such a type of the this alpha, beta, gamma, gamma double bond is present over there. So such type of the reaction are known as Claisen rearrangement reaction. And now is a third reaction which we are going to learn over here is a olefin metathesis. This is an example of pericyclic reaction. There is a 1-3 shift is occurring over there. Here is a 3-3 sigma. Why 3-3? Because they are the third there is a new bond is formed over there, and here and this old bond is broken between as a 1-1 position, and we are getting as a such type of the product over there. So this is all about the pericyclic reaction. Now let us move on to the third reaction, which is olefinic metathesis reaction. Third one, that is the C type of the reaction, is called as a olefin metathesis. C is a olefin metathesis reaction. Olefin metathesis. Olefin, as we know that it is a word name of that carbon-carbon double bond ethylene. So that is called as a olefin, means there must be a carbon-carbon double bonds are present. So that type of the species organic compound are known as olefin. So metathesis, how the reactions are occur over there. Let's see. Olefin metathesis is a formal exchange of alkyl halide fragment into alkylidine fragment into two alkenes. So let us see here. Generally here I am writing this CH2, and here I am writing as a R. Then show you and another one here CH2 double bond, and then here I am talking as a R1. You can call it as a R2 over here. R1 and R2. This is known as a vinyl compound. These are the vinyl compound, means there is a carbon-carbon double bond. So that type of the system is called as a vinyl system, right? So this is a carbon-carbon double bond, one substituent are there. So that type of the system is called as a vinyl system. And when it is treated with or vinyl system is there is a emulsion takes place, and we are going to get here carbon-carbon double bond, here R and here R. This type of the product is formed, and this product generally this one is R1, this one may be as a R2, and there is a evolution, I think C double bond CH2. Ethylene is evolved during this process. This is the ethene, right? This is a ethene, that is a side product. Side product is removed over here. Or in the above example of vinyl compound is dimerized with an expulsion of ethene. Expulsion means what? Removal of that ethylene molecule, and how this carbon-carbon double bond is formed. So that type of the olefin is known as a metathesis. So this is a new, I think these are the three reactions generally we have talked about that one. Now let us look at as a next one is a mechanism of some rearrangement reaction involving carbocation. That is the point we are going to discuss here. Mechanism So that is the main point we are going to discuss over here. Mechanism of some rearrangement reaction involving carbocation, reactions involving carbocation, and everybody knows that the carbocation means the carbon atom carries a positive charge, is known as carbocation. So carbocation rearrangement are extremely common in organic chemistry reactions and are defined as the movement of a carbocation from an unstable state to some more stable state through the use of various structural shift within the molecule is known as carbocation. And once the carbocation has shifted over to different carbon structural isomer means what? We know that in the stereochemistry how the structural isomers are there, that structural isomer further divided into as some other points are there. Let us see as a butane molecule can be there are the two isomer we are getting, one we can call it as a branch and one we can call it as a straight. So this type of the compound generally obtain, or that is called as a structural isomer. So once the carbocation has shifted over to different carbon, structural isomer is formed when alcohol or halides, the good living group, are removed from the molecule, carbocation is formed. For example, halides are the good living group, as we know that. Let us see here, suppose we have this type of the compound. I am writing over here. Here is a good living group, we can talk R1, then R2 and R3 here, right? These are the three, and when this living group is living over here, so when that living group goes outside, it taking its bonding pair, and here the carbon has the positive charge, that is known as a carbocation R1, R2 and R3. So this is the carbocation we are getting over here. L is a good living group, you have to consider over here. Carbocation, that is a what type of the geometry it has? It has a trigonal geometry over there. Trigonal geometry means the hybridization of that carbocation, trigonal geometry, this shows geometry, and the hybridization will be the sp2 hybridization, because there are the empty p orbital present over there, so it can accommodate the electron into it, and we will get as this one. And these carbocation get rearranged mostly intramolecular or intermolecularly, and these are stability of the carbocation. The stability of the carbocation is in the following order. There are some of the carbocations which I am going to show over here. Suppose we have some of the other carbocation where we can see some of the different the stability of that carbocation is in the following order. Let us see, there are some example which I am going to show over here. Let's see here how I am going to show that one. Here suppose we have this one CH-3, then that thrice C, 3 methyl group attached to this, and then there is a carbocation. This is a tertiary carbocation over there, and then let us see over here this C6H5, then CH2 positive charge. This tertiary carbocation as well as what we can call it as this allylic carbocation, they has the similar stability of that, and then next one may be as a CH2 double bond CH and the CH2. This one has a stability. And then next one maybe as a CH, which one? CH3 twice C, positive charge over there, 2 secondary carbocation. Here you can put one of the hydrogen atom, 2 3, and yes, positive charge, then CH2 positive charge, and then last one is a CH3. These are the sum of the what we can call it as a stability order of that carbocation. The stability of carbocation depend upon inductive effect, resonance effect, hyperconjugative, and the steric effect. These are the effect we already learned. And during this rearrangement, side reaction like SN1 or E1 can take place, and these rearrangement involve hydride shift or the alkyl shift. And some example of formation of non-classical rearrangement are Wagner-Merwin rearrangement, phenol-phenolone rearrangement, rearrangement of carbon chain during hydrolysis, substitution, elimination, Friedel-Crafts alkylation, and alkylation are some of the example of carbocation. Carbocation rearrangement takes place by a hydride shift, alkyl shift, or by non-classical carbocation. And tomorrow we will see the actual example how they can takes place with the help of example, with the mechanism we will see tomorrow, I think. Let us stop today here. Thank you. Have a nice day.